SOS is back, and this time we're giving you insight into Lidar, which stands for Light Detection and Ranging. We caught up with Hampton University's Atmospheric Sciences co-director, Dr. McCormick, and he told us all that we need to know. Take a look.
The light refers to a laser light. And so what we do is with that laser light we can study little tiny particles in the atmosphere, pollution particles, aerosols, dust, Saharan dust storms, that sort of thing.
Lidar originated in the early 1960s after the invention of the laser. A Lidar instrument includes a laser, a scanner, and a specialized GPS receiver. So how does Lidar work? Dr. McCormick explains.
You fire out a pulse. It scatters in all directions as it goes from little dust particles, water molecules, maybe clusters of them in the form of a cloud, or ice crystals or what have you. So it scatters in all directions. And we have a telescope sitting next to this laser because we're in the wavelengths that telescopes work. And we collect the backscatter, just a 180-degree scatter, out and back. So if we fire the pulse, we start the clock and it's 0, and then it's going at the speed of light, and we hit a cloud, we'll get a fraction backscattered, and we'll know exactly where that cloud is because we know the speed of light. And so that's the LiDAR.
In other words, a laser is pointed at a target, and the beam of light is reflected by the surface of the target. A sensor records this reflected light and measures a range. The end result is a group of elevation points called a point cloud. As Dr. McCormick mentioned, LiDAR is used to measure dust particles in the atmosphere and clouds. He explains how the information gathered is used.
We've used it for the troposphere, which is the bottom part of the atmosphere where we live and breathe, and we've also used it for things in the stratosphere, the events in the stratosphere like volcanic eruptions that put a lot of material in the atmosphere way up high if they're strong enough. And so we can map volcanic material. And all of these are tied to climate and to pollution applications.
Dr. McCormick is currently working with Lidar right here at Hampton University.
Well, we're building here at Hampton University. We've been fortunate enough to win some grants from the Army and some others, from NOAA, and we're building LiDARs. Our students are building new techniques.
Lidar is important because the information that scientists find today can help people across the world aware of the atmosphere that they live in, especially since our atmosphere is the air that we breathe.
In the lower atmosphere, we're looking at pollution, we're looking at dust storms, we're looking at clouds, and so we can characterize those clouds. We can see clouds that people can't see with their eyes and radars would never see. And so we do statistics on that kind of thing. And so you tie that all together with all the other information you have, and you know a lot about where clouds exist and how often they exist and at what altitudes they exist.
I hope that you learned why the use of LiDAR is so important when it comes to preserving our atmosphere in the future. I'm Danielle Hawkins, and this is Spotlight on Science.